This is Dr. V. Anitha Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. So in Module 1, Electrochemistry and Corrosion. So we have discussed in electrochemistry about galvanic cell. That in the galvanic cell we learnt about here EMF of the cell. Means what is EMF of the cell means the potential difference between the two electrodes in a cell is known as EMF. So what is EMF of a cell is? That is the potential difference between the two electrodes in a cell. So the potential difference between the two electrodes in a cell is known as EMF. So we can calculate EMF of a cell. EMF of a cell we can calculate by taking the formula E cell is equal to E cathode. So EMF of the cell is equal to E cathode minus E anode. So what is E? What is E? Here we wrote E cathode, E anode means. So we will discuss in the formula. So what we are going to discuss today is problems, the numerical problems on EMF of voltaic cell. So first problem, calculate the EMF of voltaic cell. So we are taking the cell here, that is we are taking in a cell two beakers. In one beaker we are taking a copper electrode and copper sulfate solution. In another beaker we are taking iron electrode and here iron sulfate solution. So these two electrodes we are taking here we have constructed in a cell, and we can see here the cell reaction, that is redox reaction taking place in the cell, and we can know the potential of these two electrodes. We have known the potential of these two electrodes. So the given electrode potential of copper and iron are, the copper electrode potential is 0.34 volt and the iron electrode potential is minus 0.44 volt. So the copper electrode potential is copper electrode potential given plus 0.34 volt and iron electrode potential, that is minus 0.44 volt. So here this how we know this electrode potential means we will connect these electrodes individually. These electrodes will connect to the standard hydrogen electrode, and we know the standard copper electrode potential, that is plus 0.34 volt and iron electrode potential minus 0.44 volt. So now in the problem the given given electrode potential of copper and iron is, that is copper is plus 0.34 volt and iron is minus 0.44 volt. So here we have to calculate the E cell, EMF of the voltaic cell. So what is the formula we apply here is E cell is equal to E cathode minus E anode. So what is E cathode means? That is the reduction potential of cathode. What is E anode means? Reduction potential of anode. So here in these two electrodes, that is copper electrode and iron electrode, so which electrode will act as a cathode, which electrode will act as an anode? Okay, so you can see the signs, positive sign, negative sign, you can make the difference here. So you can find out easily which electrode is undergoing reduction reaction, which electrode is undergoing oxidation reaction. So when we are coupling these two electrodes, and here iron electrode, that is undergoing oxidation reaction, copper electrode is undergoing a reduction reaction. Okay, so now we are taking the formula E cell is equal to E cathode minus E anode. So what is E cathode? Reduction potential of cathode minus E anode is reduction potential of anode. Reduction potential of cathode minus reduction potential of anode. So what is the reduction potential of cathode? That is the here copper electrode. Copper electrode potential is 0.34 volt, and reduction potential of anode is, that is iron electrode, that is the value given here, minus 0.44 volt. So here we can write clearly the formula, that is EMF of the cell. E means what? Electrode potential. Electrode potential. So EMF of the cell, that is E cell is equal to, we can write reduction potential of cathode minus reduction potential of anode. Reduction potential of anode. Reduction potential of cathode, reduction potential of anode. So the electrodes which will act as a cathode, the electrodes which will undergo reduction reaction, for all that electrodes potential, we give positive sign. So remember, the electrodes which are undergoing reduction reaction, okay, for that electrodes we are giving positive sign. And here the electrodes which are undergoing oxidation reaction, for all that electrodes we are giving a negative sign. So the electrodes which are acting as a cathode with respect of connecting to the standard hydrogen electrode, so we are giving here for that electrode which is undergoing reduction reaction, so we are giving positive sign. The electrode which is undergoing oxidation reaction, acting as anode with respect to, means connecting to the standard hydrogen electrode, we are giving for that electrodes which are undergoing oxidation, okay, connecting with the SHE, standard hydrogen electrode, for that electrodes we are giving negative sign. So in this formula we have to remember, it is important, we have to remember that for electrodes which act as a cathode we are giving a positive sign. For electrodes which are acting as anode, that we have to give negative sign. So here the formula is E cell is equal to E cathode minus E anode. So we have to find out here, we have to calculate EMF of the cell. So the formula is E cell is equal to reduction potential of the cathode minus reduction potential of anode. So here in this we can see in these two electrodes, the copper electrode act as a cathode and iron electrode will act as an anode. So we applied in this formula the values, okay, 0.34 volt, that is E cathode value, minus. So we have to write in the bracket because the anode value given here is, that is iron electrode potential is minus 0.44 volt. So we wrote here what, 0.34 volt minus in the bracket 0.44 volt. So we can write now 0.34 plus 0.44. So we get the answer 0.78 volt. So what we got EMF of the cell is here 0.78 volt. So to calculate EMF of the cell, we have to apply the formula, this formula, E cell is equal to E cathode minus E anode. Now next problem is calculate the EMF of the cell if reduction potential of the cell are minus 0.763 volt and 0.337 volt. So here they are giving reduction potential values. So already I discussed here what formula we have to take, that is E cell is equal to E cathode minus E anode. So always we will take electrode potential in reduction reaction only. Reduction potential of the electrodes will take. So when we take reduction potential of the electrodes, always we are giving the electrodes which are undergoing a reduction reaction, we are giving positive sign. The electrodes which are undergoing oxidation reaction, we are giving a negative sign. So here in this problem, given reduction potential of the electrodes, reduction potential of the cell, okay, what is the cell is containing? anode and cathode, 2 electrodes. Okay, so they have given 2 values here minus 0.763 volt and 0.337 volt. Now we will apply the formula. E cell is equal to E cathode minus E anode. So E cathode value here it will be, we know, okay, the electrode which will act as a cathode, that will have the positive sign, that is 0.337 volt minus, in the bracket, minus 0.763 volt, that is the electrode which in the cell which will act as anode. So we can write here that in the problem, we can do the problem, we can calculate the E cell, that is 0.337 volt plus 0.763 volt. So we are getting the answer is E cell is 1.1 volt. The third problem, calculate the EMF of the cell if the reduction potential of the cell R. Okay, so again the value is given here minus 0.76 volt and 0.34 volt. So the formula we will apply, E cell is equal to E cathode minus E anode, that is the value, cathode value, that is 0.34 volt minus E anode value is minus 0.76 volt. So here we can write 0.34 volt plus 0.76 volt. So the answer we got here, E cell is 1.1 volt. Now here we can take one more problem we can take. Calculate the EMF of the cell. If the reduction potential of the cell R, so here given the values are different. The reduction potential values minus 2.37 volt and here plus 2.87 volt. So we write plus here. So minus 2.37 volt and plus 2.87 volt. So we will apply the formula. E cell is equal to E cathode minus E anode, and we know now here which is the in the cell which electrode will act as a cathode, which electrode will act as anode. So we can look into the values, we can understand very clearly, and we can apply in the formula. That is E cathode value is that is plus 2.87 minus, in the bracket we have to write E anode value, that is minus 2.37 volt. So we can write here is equal to 2.87 volt plus 2.37 volt. So we are getting the answer is 5.24 volt. So here the answer of EMF of the cell is 5.24 volt. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.